In this section, we're going to be going over properties of the natural log function, and we're also going to be going over logarithmic differentiation. So here are some important properties of logs, which technically we should already know. The first one is the product rule for logs. It's how we expand and condense logarithms. If we have the ln of x times y, we can rewrite that as the ln of x plus the ln of y. And I'm going to skip down to 3 here. If we have the ln of a quotient, the ln of x divided by y, we can rewrite that as ln of x minus y, meaning whatever's in the denominator is getting subtracted. And I'm going to skip down to 4. If we have the ln of a power, meaning the ln of x to an exponent, ln of x to the b, we can bring down the exponent out front and rewrite that as b times the ln of x. And then this one, the second one that I skipped, is the ln of an inverse. Ln of 1 over x is the same as negative ln of x. Okay, so that would be because for 2 here, we can rewrite that as ln of x to the negative 1, because 1 over x is the same as x to the negative 1. And then we can use this power rule and bring it down front and rewrite it as negative 1 ln of x, or just negative ln of x. Okay, let's do a couple examples. Let's write ln of 5 plus 2 ln of 3 as a single logarithm. So we want to write this with just one ln. So the first thing that you have to do is we have to get rid of this 2 by using the power rule, bringing it up into the exponent. That's going to be the ln of 5 plus the ln of 3 squared. So that's the ln of 5 plus the ln of 9. Next is the product rule. Since these are being added, what we do is we combine them by multiplying them into one ln, and we get the ln of 5 times 9. So we get the ln of 45. That is 1 ln, so we are good. Next one, we want to write 1/2 ln of 4t minus ln of t squared plus 1 as a single log. So same idea as before. We need to get rid of that 1/2 by putting it in the exponent of 4t. So that's going to be ln of 4t to the 1/2 minus ln of t squared plus 1. And what we can do here is we can actually rewrite that first term. 4 to the 1/2 is the square root of 4, which is 2. And then the square root of t is just the square root of t. So 4 to the 1/2 is 2. T to the 1/2 is the square root. Okay, and now essentially one more step here. Combine these into 1 using the quotient rule because it's subtraction. That's going to be the ln of 2 radical t over t squared plus 1. And it looks like that's as far as we can simplify it, so that is our answer. And one more. We want to simplify the ln of x plus the ln of 3 plus the ln of y minus the ln of 5. So we're going to rewrite all of these using just one ln. And technically we can take care of this all in one big swipe, but let me just do it the long way at first. Let's take a look at these first two. So they're being added together. That means to combine them, we multiply them. Right, that's product rule. And now let's rewrite the other ones. Okay, now let's go ahead and take a look at these two, ln of 3x plus ln of y. That is product rule once again. We combine them by multiplying those inputs. And then the last thing here, now this is quotient rule because they're being subtracted. That's going to be the ln of 3xy divided by 5. And it's divided by because of the subtraction. Okay, so we could have done this all in one big swipe and just get the answer right away. If it's positive out front, the inputs are factors in the numerator. If it's negative out front, the factor is the input is a factor in the denominator. Okay, so now let's get into some differentiation here. Let's find the derivative of ln of x times x plus 1 times x plus 2 by first rewriting the function. So if we didn't rewrite the function, we would have to take the derivative of this, and to do that, it would be the derivative of the inside divided by the inside itself. That would be a really nasty product rule because there's 3 different factors. So let's use these rules and just rewrite it. So this is going to be product rule that we just did. All of these 3 factors are being multiplied together. So we're going to go ahead and give them their own ln, and we're going to separate them with addition because they were being multiplied. Okay, so that is f of x. That's just rewriting it. That's not the derivative. That's just rewriting it. Now let's go ahead and actually find this derivative, f prime of x. Now we do the derivative of each one of these separately because they're separated by addition or subtraction. In this case, all addition. So the derivative of the ln of x is 1 over x. The derivative of ln of x plus 1 is going to be the derivative of x plus 1, which is 1 over x plus 1, plus the derivative of the ln of x plus 2 is the derivative of x plus 2, which is 1 over x plus 2. We could simplify it by combining it into one fraction, but that would be super messy, so let's not do that. We can leave it just like that. So the rule that I was using that you have to remember is that the derivative of the ln of g of x, the ln of a function, if we take the derivative, it is g prime of x over g of x. So that was the definition from the previous section. So the last thing for this section is logarithmic differentiation. It's actually one of the most kind of important topics that we've covered in the recently, but we're going to do 2 examples here. So if we want to find the derivative of a function where there is a ton of different products, so there's a ton of things being multiplied, you don't want to have to do the product rule a million times. What you can do is use logarithmic differentiation, and to do this, we take the natural log of both sides. So we take the ln of both sides of the equation, and then we rewrite the product side, just like we did in that previous example, and then we take the derivatives of both sides, and then we solve for the desired derivative. Okay, let's see this in an example here. So first example, we want to take the derivative of x times x plus 1 times x plus 2 to the 4th. So if we were trying to do this using the product rule, we need to look at it as if there's only 2 factors at first. There's 3 different factors here, so the product rule would be super messy. Technically, it's possible to do this, but it would be super messy. So let's go ahead and use logarithmic differentiation. So the first step is we're going to take the ln of both sides. So it's the ln of g to the ln of g of x equals the ln of x times x plus 1 times x plus 2 to the 4th. And we took the ln of both sides. Now we're going to take the derivative. So the derivative of ln of g to the x, that is just the definition that we did in the previous section. That's going to be g prime of x divided by g of x. Super generic, and for these types of questions, that will always be the case. And now, oh, actually, just kidding. Before we take the derivative, what we have to do, let me just rewrite that. We'll come back to that in a second. Before we take the derivative, we have to rewrite the right-hand side using the product rule. That's going to be the ln of x plus the ln of x plus 1 plus the ln of x plus 2 to the 4th. And there's actually one more thing that we could do, and that comes down to this last term right here. We can get rid of that 4 in the exponent using the power rule. So that means we bring that out front, and it ends up looking like that. Okay, I just prefer to do that in one step so you don't have to rewrite that whole thing for that one little portion. So always do that if there's an exponent, bring it down front after you use the product rule or the quotient rule. Now we can take the derivative. Derivative of the left-hand side, like we already said, was g prime over g. Now for the derivative on the right, we can take the derivative of all of these terms individually. The derivative of the ln of x is 1 over x. The derivative of ln of x plus 1 is going to be the derivative of x plus 1, which is 1 over x plus 1, plus 4 times the derivative of ln x plus 2. Derivative of x plus 2 is 1 over x plus 2. So we're almost done. Let me just move this one away. We're almost done here. All we have to do is solve for g prime of x, and we have to do that by multiplying both sides by g of x. So if we multiply g of x to the right, we get this. G of x times that whole entire expression on the right. I'm going to rewrite that last term as 4 over x plus 2. It looks a little cleaner. And the very last thing that we have to do here is we have to rewrite g of x as what we originally started with. So if we rewrite that, we're going to get g prime of x equals x times x plus 1 times x plus 2 to the 4th. Get rid of that. And that's going to be times 1 over x plus 1 over x plus 1 plus 4 over x plus 2. Okay, so it looks a little messy, but we're just going to leave it just like that. Technically, you could distribute and clean that up a little bit, but that is completely fine for now, and that is our derivative. Okay, so let's do one more example here. Get that on the next page. And this is going to be g of x equals x squared plus 1 times x cubed minus 3 times 2x plus 5. And let's go ahead and start the same way we just did. We take the ln of both sides, so the ln of g of x equals the ln of this whole entire right side. And once again, we're doing this because we have all of these things being multiplied and it's pretty messy. Okay, so once we have the ln of both sides, now we can rewrite the right-hand side. So I'm going to leave that left-hand side alone, rewrite the right-hand side using the product rule. We give them all their own ln and separate it by addition. So we give each one of those factors its own ln, and then we add them all up. And now we can go ahead and take the derivative. Derivative of the left-hand side is going to be g prime over g. Once again, that will always be the case. It might not be g, it could be y, it could be f, it could be h, it could be anything, but it's always going to be, y prime over y, essentially. And the derivative of the first one here is going to be the derivative of the inside. Derivative of x squared plus 1 is 2x, divided by itself. Next term, we have the derivative of the inside, which is 3x squared over itself. Then we have this last term, derivative of the inside, derivative of 2x plus 5 is 2, divided by 2x plus 5. So pretty repetitive is the last one. Next, all we have to do is multiply g of x to the right. So that's going to be g of x times this whole expression on the right that we just found. And then all we have to do for the last step is replace g of x with what it originally was. And we scroll up and we see this is what g of x was. We plug that in to our answer. So we go down here and we write our derivative that we wanted was going to be g of x, which is x squared plus 1 times x cubed minus 3 times 2x plus 5. So this whole thing was g of x. And now we multiply that by whatever was left over on the right. That 2x over x squared plus 1 plus 3x squared over x cubed minus 3 plus 2 over 2x plus 5. Okay, so that is our derivative, and pretty messy again, but we're going to leave it just like that, and that is our answer, and that is logarithmic differentiation.